Hi friends, my name is Madhav. Today my topic is about maximally flat magnitude and driving point emittance function. The emittance function must be positive real function so that its synthesis can be done to obtain an electrical network using passive elements. We have discussed we have discussed the tests to confirm the positive realness of a given function. Let us study how now to synthesize the given driving point emittance function impedance. There are T types of passive elements which are an inductor L. A given function can be synthesized using any two types of passive. A network using any two types of passive elements can be synthesized generally into two forms called Foster form and Coulter form. These forms are These forms are used for the network realization because the network is realized using minimum number of passive elements using the basic forms. Hence, these forms are called conical or simple forms of realization. In each of these forms, there are two subforms. The Foster form is subdivided as Foster form 1 and Foster form 2, while the following table is useful while realizing the network by any of the four forms method using element database element resistance R 1 by R equals conductance, inductance SL 1 by SL, capacitance 1 by C equals to SC. Foster form 1. The Foster form 1 uses the function driving point impedance function. The partial fraction expansion given the equation z of s summation of the various impedance z of s equals to z1 of s plus z2 of s plus zn of s. Thus, a network can be realized by the connecting impedance z1, z2, and zn in series. Each impedance individually can be a series combination or parallel combination of elements. Combination of elements which is to be identified. The identification of the various elements existing in the different impedance function can be done by the referring tables and while finding the partial fractions. Make sure that the degree of numerator is less than the degree of the denominator. Z dash of s equals to z dash of s equals to a by s plus b. This can be synthesized by expressing it as z of s equals to 1 by s by a plus b by a. We know z of s equals to 1 by y dash of s equals to s by a plus b by a, that is equals to y1 of s plus y2 of s. The addition of two admittances indicate that there are two branches in parallel. Y dash of s equals to s by a plus b by a equals to y1 of s plus y2 of s. The addition of two admittances indicate that there are two branches in the parallel. Referring to the table on y1 of s equals to s by a represents the capacitor of 1 by a, while the y2 of s b represents conductance of referring the table 7.1 y1 of s equals to s by a represents the capacitor of 1 by a f while sorry while y2 of s equals to b by a represents conductance of b by a m which that is resistance of a by b ohms. Hence the depth of s can be realized as parallel combinations of r and c as shown in the figure as shown in the figure Thank you.